In this video, we will be focusing on cyclohexane chair conformations. Now, because cyclohexane prefers to be in a chair conformation, and because there are so many molecules that have a six-membered ring, whether it is all carbons or if it includes a heteroatom, it's very important to be able to focus on the detailed shape and conformation of cyclohexane rings. So the first thing is to think about how to actually draw the chair. So it could have a little bit of a tilt to it, or it could be a little bit straight. It's probably a little bit better like this. You might find that you can draw one direction better than the other, but what you want to do is start out by drawing two bonds that are parallel to each other. And so it could be this and then a little bit offset. And then you can draw two more bonds coming this way, again, parallel to each other. So off of this one and off of this one. And then finally, you have two more bonds that are parallel to each other that connect the red and the blue. Now, I always don't make them quite long enough, so I'll go like this, and then let's come back and make this a little bit longer. So that's what you want to do to draw a chair. If you do it a little bit more straight, then you start out with your bonds parallel, but horizontal. You can do a second set of lines like this, a little bit less of an angle than what we had on the previous one. I need to make this a little bit longer. And then let's do this. You need to be able to draw them in both directions. So whether you're doing it like this, and we also need to have the chair going in the other direction. But one thing that's really important is to make sure that you don't draw a bow tie. With this or this, even uglier versions of it, what we're looking at is this as the headrest of the chair, and this is the footrest of the chair. This is the headrest, this is the footrest. Maybe here this is even more of a hammock, but we still have a headrest and a footrest, and that's important. Over here, our chair's facing the other direction, so this is the headrest, this is the footrest. Here, I can't tell which is which. There's no obvious headrest, there's no obvious footrest, it is just a bow tie. This does not work for cyclohexane conformations. In each of these cases where we're drawing a chair, we are drawing it basically perpendicular to the plane of the screen, perpendicular to the plane of the paper. Okay, so this bond here is always in front. The lower bond is coming in front of the plane, and then that means that this one here is back behind the plane. So that really means that your headrest carbon and your footrest carbon are in the plane of the paper. Okay, your headrest carbon and your footrest carbon are in the plane of the paper. This bond is in front, and so we could think of this as a wedge because this is coming forward, and then we can just draw this thick because it's in front. This one would also be a wedge. And then this one would be a dashed line. We're going back, and then this is behind the plane. Now we don't have to draw, in fact, we don't draw the wedge and the dash, but I just want you to be able to see what this refers to. If you want to draw your one line a little bit darker to remind you that that's in front, you are absolutely welcome to do that. This is in front. This is in front, you're welcome to do that. But typically this is what we use, is that the lower bond is the one in front, the higher bond is the one that is in the back. Now I've included the framework for chairs that you need to fill in on the next several slides, but please practice drawing chairs in both directions with the headrest to the right and with the headrest to the left. You need to practice so that we can communicate with structures. Now we need to fill in some details on our cyclohexane rings. So first of all, let's keep in mind that we can draw cyclohexane like this, flat, and then we have hydrogens in front and we have hydrogens back behind. Okay, so all of the green hydrogens are on the front face and all of the yellow hydrogens are on the back face. Now, how do we go from a flat representation to a chair representation where we are showing conformation? So here we have two chairs pointing in different directions, and in each case, this is the bond that is in front, this is the bond that's behind the plane, this is in front of the plane, this is behind the plane. I like to start out with the headrest and the footrest because the shape is the most clear to me there. Keep in mind all of these carbons are sp3 hybridized, and so we have a tetrahedral arrangement. Well, with this bond kind of going that way and this bond going this way, then we have another bond that is going to be going straight up from the headrest and one that is straight down from the footrest. Once we put in our hydrogens that are straight up and straight down, then we can alternate. So at every zigzag, we're going to have a hydrogen going straight down or straight up. And also notice this zigzag is pointing down, so the hydrogen is down. This zigzag is pointing up, so the hydrogen is up. Here our hydrogen is up, and here our hydrogen is down, but remember that is back behind the plane, so this bond is behind this bond. Now, once we have filled in all of our hydrogens pointing up and pointing down, now we can fill in the other hydrogens connected to each carbon atom. Keep in mind we have a tetrahedral arrangement, and so from here, if we were to draw a bond straight out, that would be 90 degrees, and that's not tetrahedral. So we're going to have a bond coming this way, but it's going to be down a little bit. So instead of drawing it straight out, it's going to be a little bit down. Here's a hydrogen. Because this one is down, our next one is going to be a little bit up. These are a little bit harder to see. This is coming forward. Here's our hydrogen a little bit down. Because this one is down, this one will be a little bit up. This one will be a little bit down. And then this one is going back behind. So looking at each carbon, we have a tetrahedral arrangement. All right, now, how does this relate to this? So I always do it so that whatever is my front face when I'm drawing it flat becomes my top face. So here it doesn't matter, but I like to think about this carbon, my headrest, as carbon 1, and let's just call this one carbon 1, and then 2, 3, 4, 5, and 6. On carbon 1, on my front face is a green hydrogen, so on my top face, I make that a green hydrogen. On carbon 2, my front face is green, so now at this carbon 2, I have this on my top face and this on my bottom face. So this is the one that is green. This is my front face. Over here, this is the one on the front face or the top face. This is the top face, and top face. So I should have 6 hydrogens that are on the top face that are all green. So the front face becomes the top face. But notice that these green hydrogens include 3 that are sticking straight up and 3 others that are sticking out and only a little bit up. So these, it's really easy to tell that they are on the top face. With these, it's a little bit harder. Now let's fill in the hydrogens from the back face. and that's going to be all the others. Once again, the ones that are pointing straight down, that should be easy to tell that we're talking about the back face is the bottom face, and this one. But then we also have the ones that are sticking out and a little bit down. So this one is on the back or bottom face, this is back or bottom, and this is back or bottom. So we have to be careful. Well, it doesn't matter so much when we have all hydrogens, but it's really good to practice now when we're only using hydrogens, because pretty soon we're going to be looking at substituted cyclohexanes. And we want to make sure that we are going from our flat structure into a correct chair. Now let's try that again on the other chair. And once again, we can start with a headrest and draw a hydrogen straight up. At the footrest, a hydrogen straight down. Next, let's go around the ring, starting here with our hydrogen straight up. At the next zigzag, this hydrogen is straight down. And remember, this bond is behind the plane, so this bond is behind this bond. Here we're straight up, here we're straight down, here we're straight up, and here we're straight down. And then we can fill in the other set. So because this one is straight up, this one will be out and a little bit down. Because this one is down, this one will be out and just a little bit up. This one is kind of coming forward. Because this one's down, this one is out and a little bit up. Because this one's up, out and a little bit down. And then this one is going kind of back behind. I tend to draw these with shorter bonds, kind of to show the perspective. So these are just way back. Please be careful when you are drawing your bonds that are sticking out. I don't want it exactly 90 degrees because that's not very accurate. I also don't want it like this because it's not pointing down that much either. So please be careful when it comes to drawing your bonds. Now, there are a couple things that we need to focus on. Okay, let me erase those other red bonds that I drew. And let's put that one back. Okay, now let's again identify the hydrogens that are on the front face and the back face. So the front face in our flat structure will be the top face in our chair structure. So these are on top. And then if we look at this carbon, this must be the bottom face and this must be the top face. So this is the top face. Over here, we already have our top face going straight up. Here we have our bottom face straight down, so this one must be our top face going out and just a little bit up. And then back here, this is our hydrogen on the top face because the other hydrogen connected to that carbon is going straight down. So we should have 6 hydrogens from our top face, and now the bottom face, the ones going straight down, are easy to find. Those are definitely on the bottom face of the chair, which was the back face of the flat ring. Now looking at this carbon, this hydrogen is up, so this one must be the one on the bottom face. This one is bottom face, and this one is bottom face. As we are looking at chair conformations, we can think about kind of an equator of the ring. So where these carbons are, and then going straight out from them, we have a set of equatorial hydrogens. And so here, the equatorial hydrogens are all colored blue. And so these are the ones that are out and a little bit down or out and a little bit up. Then, in addition to the equatorial hydrogens, we have axial hydrogens. These are the red ones sticking straight up or straight down. The pink ones or the red ones, these are axial, and the blue ones are equatorial. So coming back up and looking at these structures, here we have, let's see, this hydrogen is axial, axial, axial. These are the easy ones. Straight down, axial, axial, and axial. But notice, 3 of our axial hydrogens are from the front face, 3 of our axial hydrogens are from the back face. Now this one is equatorial, 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 and equatorial. Over here, equatorial, 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 and equatorial. And then axial, 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 and oh, here we go, and axial. So we have 3 of our back face are axial, the yellow ones, and red. We have 3 of our back face, yellow, are blue, equatorial. So there are a few different ways that you need to be able to look at your ring and look at your drawing, because we have to focus on which groups are on the front face and the back face, and we have to focus on which groups are axial and which groups are equatorial. So, number 1, practice drawing your chairs. Number 2, practice filling in the groups on the chair, and then make sure that you can identify your axial and your equatorial hydrogens. Now, once we have a chair conformation, we have to be able to show how it changes to other conformations. So here's our headrest, here's our footrest. Although we don't have the same type of free rotation that we see with a straight chain alkane, these can still take on different conformations. So we can think about our headrest can fold down to give us a boat, and then our footrest can fold up to give us the opposite chair. I want you to be able to draw the interconversion between chair conformations. So we can call this chair-chair interconversion, chair-chair inversion. We can also call it, and your book calls it, a chair flip, but I don't want to use that just because in the past I've had students who, with the word flip, they think of it as picking up the whole chair and flipping it upside down. So I'm not going to use that. I want to stick with inversion or interconversion, because what we're doing here is we are imagining that this is carbon 1, 2, 3, 4, 5, and 6. And then when we draw our other chair, they are going to be in the same relative position. So we are imagining that this folds down. Therefore, this is carbon 1. What used to be the headrest is now the footrest. And then this is carbon 2, 3, 4, because this folded up so that our footrest became our headrest. And then this is 5 and 6. So remember, this is in front. And when we do the interconversion, when the headrest folds down, when the footrest folds up, this is still in the front. And so it's very important to be able to keep track of where carbon 1 is to start, where carbon 1 is to end, where's carbon 2 to start and end, etc. I find it easiest. I always start with carbon 1 as my headrest. And I always think about it as headrest and footrest are changing to footrest and headrest. And then if you are going, well, if you're looking at it from the top, if you're going clockwise, make sure your numbering still goes clockwise. If we are starting with this chair, then again, we want to picture our headrest becoming our footrest becoming our headrest. So our other chair is going to look something like this. If this was carbon 1, 2, 3, 4, 5, 6, then this is 1, back behind is 2, 3, 4, 5, and 6. It doesn't matter where you start your carbon number 1. It doesn't matter whether you number clockwise or counterclockwise. But what does matter is that however you draw your first chair, your interconverted chair must have the same relative direction of numbering and of substitution. Now, let's also take a look at what happens to our hydrogens when we do a chair interconversion. So from the previous slide, we had everything on the front face, or now the top face, was green. So here we have one of our axial hydrogens, and axial hydrogens. And then our bottom face was yellow, axial, back here, axial, and axial. And then if we fill in our equatorial, and back here is equatorial. And then this is our equatorial on the bottom face, equatorial on the bottom face, and equatorial on the bottom face. So we have axial, 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 and these are equatorial. All right, now, as we do our interconversion so that our headrest folds down to become our footrest, this is carbon 1. So now from carbon 1, we are going to have a hydrogen going straight down and a hydrogen going out and a little bit up. Right? Instead of having a hydrogen going straight up and one going out and a little bit down, now we have a hydrogen straight down and another one going out and a little bit up. Which hydrogens are these? Because we just folded this down, we're now looking at this is our bottom face and this is our top face. So this is still our green hydrogen that was on the top face and it's still on the top face. And then this is our yellow hydrogen that started out on the bottom face and is still on the bottom face. But notice what did change is that here our green hydrogen was axial, but now it is equatorial. And our yellow hydrogen was equatorial, now it is axial. So whenever you do a correct ring inversion, your axial will become equatorial and your equatorial will become axial. Okay, I'm going to stop doing quite so many colors, but let's fill in the details on the bottom one. So here is a hydrogen straight up and straight down, straight up, straight down, straight up, and straight down. And then here we have our equatorial, 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 and equatorial. Focusing on carbon 1, this folds down so that this is now carbon 1. And now we're going to have a hydrogen straight down and a hydrogen out and a little bit up. Where we started, this hydrogen was on the front face of the ring or the top face of the chair. And now that is this one. And this one was on the bottom face, and that's now this one. So once again, what started out equatorial is now axial. What started out axial is now equatorial. So you should fill in the rest of the hydrogens, do your interconversion, convert your footrest to your headrest to your footrest, fill in your hydrogens, and double check where they all go. You should always have one axial, one equatorial on each carbon. You always have your hydrogens pointing straight up and straight down at your zigzags. And then if your axial is straight down, your equatorial will be out and a little up. If your axial is straight up, your equatorial will be out and a little bit down. I highly recommend that, first of all, when you are starting with your flat structure, go ahead and number those carbons. and then number these carbons corresponding to these carbons, and then double check number these carbons corresponding to these carbons as well. That way you can make sure that you didn't go from having a substituent at C1, C2 that were cis to each other, and then here you drew it at C1 to C3, and then here you have it at C1 to C3, but they're trans to each other. So numbering and going slowly is going to be very, very helpful. Practice now, because in the next video we are going to start looking at substituted cyclohexanes, and it's much more important to pay attention to the location of our substituents when they're not all hydrogens.